want to go ahead and start us off?
Okay, we'll get started. Thank you all for being here today. And those of you online joining us to the Construction Hoist Council. I'm Eric Schmidt with Century Elevators.
And I'm Shannon Beekman with Fracco Products.
And again, glad to have you with us. All right, we'll get started. Yeah, go ahead.
All right, so I'll go ahead and start the presentation. And with it, we can't talk about the Construction Hoist Council without talking about what's going on with personnel material hoist standards in the US and Canada. So right now in the US, we cover the ANSI ASSP A10.5, which is the safety requirements for material hoist. And then we have the ANSI ASSP 10.4, which is for personnel hoist. Now, we did this big project on the 10.5 where we just rewrote the whole standard. And a lot of people in this, in the SAI helped with this. There's a lot of us that are in the A10 committee, A10.5, and we actually got that standard published, and it's been released since August of 2020. And the big rewrite of this was to include products that didn't really have a home, some of the scaffold material hoists that are out there. Like I said, it was a complete rewrite of the standard, and it's now released, and I don't know if anybody's actually read it yet or if they're actually using it. Anybody here in the room has actually started using that standard? What was that, Sean? Oh. All right, maybe one. The next is the 10.4. The 10.4, we are actually in the middle of a rewrite. And I think the last time during the committee week, we are looking for feedback from everybody in the council. Right now, we're in the rewrite stage. We need to know if you're having any problems or issues with your local areas, things that we can address in the standard to make that easier. Yeah, or anything that's unclear. So part of that is in the rewrite, we got the scope and equipment covered. We have the structural design, current allowable stress limits, types of elevation for design. These are all things that we're talking about. Definitions, do we need to change our definitions? A10 went through a whole thing where they harmonized all their definitions, similar like the A92 did. So some definitions work, some don't, so we have to reconstruct some of them. I don't know where that underline came from. Did you guys line my, or did I do it? Car size and capacity limits. We've had some issues in different parts of the country. New York had it where with limitations, first they were starting out with allowing the really extended personnel hoist, and then you had baffles in there. So then you had non-loading zones. Well, I think now they've gone back to where they've added sections of the 2016 standard of 10.4 to where now you don't do that anymore. You can't do that anymore, and now you have to have load cells and follow the regulations. Types of controls permitted. We've had some incidents with automatic controls that are causing problems where there's been deaths. So we're reviewing some of those controls and if there's extra requirements that are needed when you use different controls. And then types of anchoring the structure. And then inspection and certification requirements. One thing we're going to do with the 10.4, like we did with the 10.5, is add more guidelines for inspections, more guidelines for training, and who has responsibility of certain aspects of the standard or of the personnel hoist. Hot topics right now in the rewrite that we've been talking about is buffers, use of hydraulic instead of spring. And this is a big issue, and we're looking at this. And part of that is I am challenging the A17.1 buffer subcommittee, because right now, if you have a machine, if you're following 2007 machine over 200 feet per minute, you got to have a hydraulic buffer. Well, during an acceptance test, you have to perform a buffer test. And that buffer test, we refer back to the A17.1. And in that standard, it states that you have to run fully loaded at rated speed and hit the buffer, the hydraulic buffer. That's the test. But that test might work for hydraulic machines, it might work for traction machines, but that test does not work with rack and pinion machines. So I don't know, people in the audience here, have you guys ran into problems with your hydraulic buffers or running this test or anything of that? Because if you have, I like to know if you have any pictures of damages, because it adds to it. You know, I know you had something in the past. Yeah, so basically what happens is when you have a rack and pinion machine, when you're traveling at full speed, you don't have the down stop anymore, and you don't have the over travel. They've both been eliminated out of the system when you run this test. So now you have a machine running at full load, at rated speed, hitting the hydraulic buffer, and once it bottoms out, there's no way to stop it. Now you can wire in the over travel, but have it very close to the bottom, but there's really no way to get rid of the inertia that comes from those engines or from the electric motors to stop that machine in time. If you have a hydraulic elevator, usually when it deadheads, you're going to have the main pressure bypass. So you have a safety in there. When you have a traction machine and it deadheads, you're going to have a slack rope situation, which is going to cause a narrow limit switch to kill power to those motors. Rack and pinion, you don't. So this is a challenge that I'm trying to present to the A17-1 buffer subcommittee to review this, because this test for me, for rack and pinion, is unsafe. Next is motor brakes test for multiple motors and multiple masts. We're now having larger personnel hoists that we have dual mast systems, multiple motors to handle the loads. Well, then now we have requirements for motor brakes. And how do we test those motor brakes? Are we required to have every motor brake handle that load? Because I don't know of a motor manufacturer or brake out there that can handle the full load of the machine by itself. So what's the correct combinations for testing these machines? Nothing really goes past 2 motors in the standard right now. And then calculation of hoist square footage. We had from 2007 to 2016, we had a change in the square footage calculation when it came to if you had a load cell, you can drop down to 82 pounds per square foot. And there was an interpretation that was written a while back on how to calculate that. But what happens is, where do we actually measure it at? There's no defining terms of where we measure it. If you look at A17-1, where a lot of this came from, you have to measure it about 32, 36 inches up from the floor. That's where you measure your square footage. Or do you measure it to your doors or to the door seal? And there's no indication how deep your door seal is. I mean, I could have a car that is probably 60 inches wide. My door at the end is only 48 inches wide. So now I have the space of that door that might be 6 inches. That's considered my door seal. So I only measure to the edge where I'm 60 inches wide to the other end of the car. But if I want to extend that, there's no thing that stops you from making that a 36-inch door seal. No regulations in there on that. So we're addressing those to get our square footage. And now it's not clicking. All right. No, I broke it. Yeah. All right, so now there's some new news in the A10. So we have the discontinuation of the ANSI ASSP A10.22, which is the safety requirements for rope guided and non-rope guided workers hoist. Now, for me in elevators and hoists, you know, personnel hoist, material hoist, this doesn't really affect me, but now it does, because it's been voted in March of 2021 to merge those different requirements and those standards into either the 10.4 or the 10.5. So things that fall under personnel hoisting will go into 10.4. Things that fall under 10.5, well, under material hoist, we go into 10.5. I don't know if anybody uses this standard, but what it entails is a non-guided workman's hoist is a hoist involving a transportation of a person, such as a boatswain's chair or equivalent, not attached to fixed guide ropes. So if anybody uses boatswain's chairs, that falls under the standard. This will then become part of the 10-4. Rope guided workers hoist. We have workers hoist assembled in which the travel of the cage is guided by wire ropes and from a hoist using anchored rail attachments. That type of system will fall in there as well. This could either fall into a 10.5 situation if it's material only, or if you have a man basket situation with guided ropes, it would fall into a 10.4 situation. Well, it was withdrawn because they weren't selling the standard anymore. They didn't have many sales of the standard. They didn't want to, there was no, it kept getting reaffirmed and nothing was changed with the standard. Yes, James. That I don't know. I don't know those details. I know there's probably people here that use bosun's chairs. I think Sunbelt had some in their fleet that they use. They're used daily. Yeah.
But we're not familiar with these types of hoists because they were not part of the 10.5 or the 10.4. So, we just finished the rewrite on 10.5, and now it looks like we may have to add another section back again.
Can you talk into the mic? Just have a question. Yeah, they can hear you online.
So with that, if anybody here has experience with this stuff, I could use your help. We could use your help on getting some information to categorize the different areas into the 10.4 and 10.5, because ASSP is going to have us do that.
Just did a search on workers hoist, workman's hoist, and all of the references I'm seeing here is elevator industry. So I'm wondering if we're talking about a different piece of equipment, because obviously a powered bosun's chair already has a set of rules that it adheres to. And now all of a sudden we're going to be moving that out of suspended scaffolding over to this. So we really need to get a clarification on exactly what type, or if all, of bosun's chairs is what we're talking about.
Yeah. Okay. Okay. Part of this, I'm thinking with some of the standard, there's going to be some overlap in a lot of other standards. And that's one of those things where as we rewrite the 10.4, we then have to add this, or is there sections of this that we don't need to add into there to where, because it's covered in another standard? Those are things that we're going to be looking at too. Yeah, it makes it more complicated. Also, as mentioned in committee week of 2020, we talked about once the 10.5 standard was published, we were going to do a standards for material hoist, that how it would affect the industry, do a industry awareness document. We're going to kind of put that on hold a little bit until we get done reviewing this 1022, because what's going to happen is we do the 10.4, add the 1022 stuff, and then we have to take the 10.5 and whatever comes out of the 1022 to go into 10.5, we have to rewrite the 10.5 to include those items. So it's a possibility we have a 10.5 2020. You might then have a 10.5 2022 come out pretty soon, because we have to make changes before they can remove this. Canada. So a long time, there hasn't been much happening with Canada with their standards as far as when it comes to the Z256 for material hoist or the Z185 for personnel hoist. But like I said, there has been a lot of work. There has been no revision since 1987 to those standards. They were just reaffirmed in December of 2020. They are working on a project. I sit on these committees. They are working on a project to try to open up a project to begin re-looking at these standards. They need some help. If anybody works in those markets, interested, let me know. I can get you in the right people to talk to if you're interested in helping out in those standards. I know for the longest time, there's been a lot of questions. I've had a lot of companies come to me because working in that area and with these standards, that how do we make them move forward and stuff. And there's actually, people are now starting to I guess fuel that engine to get it going. So, but they need some help. There's some issues with the Canadian government and funding and stuff like that. So, but if you want to learn about it, you can talk to me offline here. So next we have guidelines of operator training, construction elevators, material hoist. That's something that we talked about in 2020. If you want to go ahead and cover this, I'll pass it on. The green button.
Okay, so we're not talking about creating a training document or a training standard, just the main points that as a consensus industry group that we would like to see recommended to anyone doing operator training. And so it would cover hazard awareness. What are the main risks of either injury or damage to equipment, damage to structure? Stop work authority and responsibility, that the operator needs to understand that they are the gatekeeper, that they have ultimate responsibility to shut it down, keep it from operating if there's a hazardous situation or if there's an unknown situation. If somebody wants to come up and load the elevator with equipment, but they don't know exactly what the weight is, the operator is authorized to not take that load until they know what the load is going to be. We will also suggest that there will be some review of the portions of the ANSI A10.4 that are important to the operator. Some clearances on floor landings. What's the allowable distance between the elevator car door and the landing door on the structure? What's required at the base? What's required for different situations under emergencies? Base enclosure, the base platform, gates, or what's required at the landings, what's the placement, how is it supported? Car clearances as it travels up and down the hoistway at the landings. If you're up against scaffolding, what's the requirements there? Other obstructions. And then buffers, what are the buffer requirements? Let the operator know what the safety device does and when it might become engaged, what to do if you believe that the safety device is engaged. Right. If you're in a loss of power situation and you need to use a manual descent to get to a floor to offload the elevator, you want to make sure that you're not engaging the safety device. So those are all things that should be required during training. And then you get into your normal control limits, your final limit, your up limit, your down limits, how to operate, what are the normal controls used every day? How do you communicate with the landing levels? That's got to be discussed, have to have a plan in place. Use of hoist for carrying materials. What are the types of materials that you're going to be carrying? What's allowed to be carried? What happens with rolling equipment? What if it's powered rolling equipment? What do you do when someone's trying to load this onto the elevator car? What's the plan for moving materials with personnel? Do you know what is involved with maintenance, inspections, testing? So these are all things that are important for the operator to be aware of. We think that an operator that has a better overall knowledge of these categories, that they will be a better, well-informed operator. And then recognizing any kind of deficiencies, any damages, what to do when there are, recognizing these damages, loading, we just talked about that, like maximum capacity and where should that load be placed. That's very important. Anyone involved in the engineering side knows that you want to try to have centrically loaded placement. There's the gatekeeper I mentioned before. Prevent overloading and prevent improper usage, making sure that the rules are being followed, making sure that the equipment's not being damaged, and noting, again, if there are damages that are observed. And part of the inspection process, monitoring the equipment, the path of the elevator car and other components. Power cables, very important. Make sure that that power cable is unobstructed. And then if you're always going to have severe conditions, weather, high winds, electrical storms. What happens with loss of power? In an emergency situation, what are the procedures? What is the plan? And that's it. Okay.
So we're switching back and forth here. So now, after that, any questions about the operator guidelines that we're looking at doing? So gap analysis, like every other council, we're working on gap analysis on the standards compared to OSHA and where those differences lay. So right now we're working on, now when we start talking about material hoist and personnel hoist, it gets very complicated when it comes to some of the regulations. So we have OSHA, so we're looking at the regulations of OSHA with personnel hoist, material hoist, and it's very, very small section. And then we also are looking at regulations of personnel hoist, material hoist for the 22 states that have their own state funded OSHA. They have their own state regulated OSHA. And with that, it kind of boils down is I'm gonna start putting together a map of this. And it's a big project to do because we have the states, we have the OSHA. Then when we get to the states, we have the states that then have the regulations that they override. Like in some of the 22 states, you have Cal OSHA that has their own regulations that they do. You have other states that do the same thing. And then when you get to like Michigan, you'll have regulations in Michigan. But then when you get to the city of Detroit, they have their own added regulations on top of that. So it starts boiling down where all those different areas, it starts feeding out to where you have all these different components there. So it's a project. I'm starting to map it out a little bit on what regulations and where and who's accepted what and when. A lot of the states, they look at the 10.4, the different year versions as adding those regulations into their building codes as well. So there's that side of it as well. So if anybody wants to help me with this project, I'd appreciate the help. But it's pretty big. Oh yeah. So for the longest time, we look at 1926.554 C16, which is the OSHA regulation where it talks about all personnel hoist should follow under A10.4 1963. But then after that, there's in that same paragraph, the following sentences, but 16C does not apply to cantilevered hoists. So personnel hoists now that we use now, aren't they all cantilevered? So that rule doesn't even apply if you go by that standard. So what rules do then? And that's where the big hiccup is between OSHA and the regulations of the states. Yeah, 63. California, they're a little bit closer. They're at 73. They use 10.473 as their referencing for their regulations. And then they've had moderate, if you look at their permanent elevator side, or I wouldn't say permanent, but general public elevators, the A17 side, they're at 2004 for that side of it. So there's all this jumping around between the standards. Like I said, it's a big mapping project. Any other questions?
So I got left.
I'll say it in Scottish, right? One question I had with regard to the proposed operator training guidelines is, and you touched on it a little bit, which was wind, right? Is there any further reference to wind? And I'm talking specifically, I get a lot of questions from inspectorates around asking me about wind speed, okay? Is it sustained or is it gusting, right? And I usually give them a very kind of bland, grey answer because that's all I've got, right? And that's really all we all have, right?
Yeah.
And I just wondered if there was any if you had any considerations about dealing with any of that in the operator training side, because somebody at some point is going to come up and say, well, the operator should monitor the wind speed, right? Then the question is, what do you do about it if you're monitoring it, you know? So I just wondered if you had thought about it to stay away from it, or was it worth addressing, or?
I'm not sure what your opinion is of it. My opinion is of it, I would think it was more of a stain for a certain period of time. I don't know. I'm not fully
Well, but if you start to get wind gusts that are, you know, the standards usually are centered around a maximum near 35 miles per hour. So if you start getting wind gusts near 35 miles per hour, you're probably going to start to have a problem with some operational issues. So for instance, you may need to start monitoring the power cable more closely because it could whip around and you could get wrapped up in obstructions or get outside cable guides, whatever may be the case. But most of the structural aspects of an operating car are calculated with winds in that 35 to 40 mile per hour range. So if you start hitting anything close to that, you're getting into the maximum design requirements. So especially when your wall tie forces, most of them are rated for the operating car. You know, a lot of times your 90, 100 mile an hour storm wind conditions are not the critical factors. They're not the critical loads on your wall ties, because when the car's in the air, it's a big billboard essentially. And so your forces in operating winds in general can be higher than the storm wind conditions with the car parked at the base. But in general, when you're talking to potential elevator operators, you definitely need to be talking, in my opinion anyway, talking about gusts that are approaching 35 miles per hour. I prefer that they would keep it below 30, to be honest.
So you're looking at it as gusts and not like sustained wind at that point.
Yeah, and that's for me, that's the question that comes up a lot, right? I even looked at EN 1495, which is the mast climber standard, right, European, and they reference a crane calculation of wind within the standard, right? As a way of obviously examining or determining, right? I haven't managed to get hold of that standard yet, but somebody looked at it, right? And Eric, like what you said, I mean, I'll always say, hey, you know, the guys will be off the unit before the wind gets to 35 miles per hour, right? I mean, you're right, there are operational challenges. Right. But the question's coming up because somebody's out there also marketing an alarm that you can put on the side of a mast climber or a scaffold or a hoist that will basically set off a siren, right, when the wind gets to a certain speed, right? And the question I've got then is, well, if the wind is, let's say 25 miles an hour, right, and it's gusting at 40 and the alarm goes off, do you want it to gust at 40 for 3 seconds or 120 seconds, or, you know? And that's where the problem comes in. Yeah. So I was just looking at it from a way of negotiating people away from that argument, you know. And how much of it do you really want to talk about in operator training? You know?
Yeah, I think that's where I looked at it as being sustained for a certain amount of time, you know.
Right, but I also look at let's look at your example. You said 25 mile per hour with winds that are gusting higher. You know, I would rather have the contractor err in the side of safety. And a lot of times I'll tell them, it's just like, do you want the elevator to be operating tomorrow? You know, so it's not as much safety as it is being able to provide that production efficiency. Yeah, you know, you want the elevator running. You don't want the elevator shut down. So don't push the limits. And, you know, sometimes that's successful. But again, you know, anytime you're approaching that 30 mile an hour wind or slightly higher than that, whether it's a gust or whether sustained winds, you know, they really should start taking precautions, maybe extra eyes on that trailing cable as it's operating.
Sean, did you have a question? No? You did, but you didn't. Any other questions?
Shannon mentioned very briefly the part about the cantilevered car. And I think I've read that section of the OSHA 1926 many times and just kind of skipped right over it because it's, you know, 6 or 7 words. I mean, it's very short and brief, but, you know, essentially, if you follow what the words actually say, many of the elevators that are out on the street that you would see around Miami or any other city would be exempt from that section. So I think we just have to keep moving forward. I'm not sure how many people are using the 1963 copy of the A10.4. I'm not sure I've ever seen one. I don't know.
It's like 6 pages long.
I've never seen that one before. So, you know, we keep moving forward, trying to present the best industry documents. I don't know how we get governmental regulators to recognize current versions. You know, like you said, you know, you're looking at 2001, 2004, 1973. You know, we've got old standards that have been replaced by many hours of work from experts in the industry to get there.
You got new technologies, you got new practices, you know, you have all these new things that have occurred since that time frame to now. You know, you have structural differences, you know, that we talked about, the length of a car and the beams and the amount of weight, and those standards now, metal's a lot different now, and what they produce now compared to what they produced back at that time.
Gene.
I know you guys are talking all about operational issues of the hoist, but have you addressed the tie butter standards? I mean, what is the safety factor for ties and butters on the hoist?
On construct, are you talking about the 10.4 or 10.5 equipment?
Yes.
Yeah, I mean, you're using, it's not a straight 2-to-1 or 3-to-1 ratio. It's, you know, it's the design standard, part of the standard now has requirements that, you know, putting loads in the worst case and applying a certain amount of wind to evaluate the wall tie without failure. So it's not a straight numerical safety factor.
And a lot of that's based on the location of where it's going in at too. Some of those factors.
Yes. So that's something that's determined by the manufacturer. It's not, there's not a standard that requires a certain.
Well, the standard does have requirements for the design and manufacturing. So you'd have to go to that section. And so from an operational standpoint, basically the loads, load resistance, the attachment would come from the manufacturer's guidelines. You know, their manual should tell you these are the forces that you're anchoring. And because they're the ones doing the analysis and looking at winds, maximum operating winds, maximum spacings, and those kind of things.
And
So
location is a big part of that.
yeah. There's a lot of manufacturers that are now putting out charts that are based on the space. So if, let's just say you're at, you know, a 30-foot spacing or a 20-foot spacing, hopefully you're going to start seeing more charts that will give you the difference in forces based on that difference in vertical spacing.
Thank you.
All right, come on, Dave.
Back to the operator guidelines, the training guidelines. I agree that having those guidelines are an excellent idea. But one of the problems I think we're going to run into is more of a site cultural issue. All right, so you go out on any of your GC job sites, you know, they're going to supply an operator that they don't trust to push a broom. And you're going to expect these GCs to give these operators a stop work authority when they don't even trust them to push a broom. I think that's more of an issue that we're going to have to combat over the long term than whether we're actually explaining the enclosure height requirements for material hoist at the landing level. Does that make sense?
I get what you're saying. A lot of that happens in the field. But in the sense of it is the operator of that machine, you know, it's just like hopping in a vehicle with somebody. You know, you're hoping that that person driving that car or that truck is going to follow the street signs, you know, stop at the red lights and follow the regulations and stuff to drive. And it's the same thing with this equipment. That operator needs to know or have the authority that, hey, something doesn't look right, we can't run this machine, you know? And that's where that culture on a job site is gonna have to change a little bit, you know? And that, like you said, that is a tough thing to do, but they're gonna have to do that because they're the people that are the first line of defense is that operator. for safety.
And I agree with what you're saying, that happens every day in the field. And some of it's up to us, though. You know, if you say, now, you tell the superintendents, the guys in the field that know what happens when the elevator shut down. You know, say, how important is this machine to you, to your job? So make sure you put someone that is responsible and accountable. And it's not always going to happen. But, you know, I urge that over and over again, that they use someone that has accountability. You know, keep it clean, keep it undamaged, make sure that you're not getting it overloaded. And that inspection process, you know, look at the power cable. You know, every time you get out, look up, make sure it's not caught somewhere. So just, there's a few things that an operator has control of that can avoid shutdowns and major delays.
Any other questions? All right. Well, thank you, everybody, for your time today.
Great job, gentlemen. Thank you.
Okay, we will be back here at 3 p.m. Eastern for the supported council session.